Analyzing a shifted hyperbola is very similar to analyzing a shifted ellipse. Use your prior experience with shifted ellipses to complete the tasks below. First, given the equation x minus 4 squared over 16 minus y plus 1 squared over 9 equal to 1, where is the hyperbola centered? Well, as we said, this is very similar to an ellipse and to a circle or any other conic section. We simply look at the x and the y terms and apply the old x minus h squared y minus k squared rule of thumb. So in this case, h equals 4 and k equals -1. Remember, the +1 produces the -1 result. So from those, we can say that the center is at 4, -1. Knowing that the asymptotes of a hyperbola pass through the center, write equations for the asymptotes in the problem above. Well, we know that the original form of our asymptotes were for a horizontally oriented hyperbola, y equals plus or minus b over a x. So the really important part of this is the slope. Okay, so from our earlier work up here, we can say that a is equal to 4 and also b is equal to 3. So we will have a slope of plus or minus 3 over 4. Now I'm not including the x because what I want us to keep in mind is that the asymptotes of the hyperbola pass through the center. So we have to make an equation for the asymptote using point slope form. And that point in question is going to be the center. So our equations for the asymptotes will be, remember point slope form is y minus y1 equals the slope times x minus x1. So for us, it's going to be y plus 1, right? Y minus a -1 equals plus or minus 3/4 times x minus x1. That's that 4 from our center. Now, all components of a hyperbola are oriented around that center hk. We can use this fact to fill in the blanks below. Write small. I'm going to zoom in. We're going to start with a horizontally oriented shifted hyperbola. The equation of a hyperbola with center at hk and a horizontal transverse axis has the following properties. If we begin with that equation, x minus h squared over a squared, etc., then our vertices happen at h plus or minus a and k. And we could visualize that by thinking about if here's the center of my hyperbola, and here's a vertex, and here's a vertex, this is my a value. So the difference in the x coordinate will be my center, right? My center was hk. The difference, the distance from the vertex to the center will be over here, h plus a, and the y hasn't moved. Y is still k. If we look in the other direction, it's going to be h minus a, and again k. And that same behavior will hold for our other points, so we won't be as explicit with them. The foci create a similar pattern. We're going to have h plus or minus c, and again k, where c squared is equal to a squared plus b squared. Transverse axis still 2a, right? Two of those a's, total of 2a. And the asymptotes. Well, the asymptotes we just did. The asymptotes, as we noted, were y minus the y coordinate of your center and plus or minus b over a, x minus the x coordinate of your center. Repeat the process for a vertical hyperbola. Vertical shifted hyperbola. The equation of a hyperbola with the center at hk and a vertical transverse axis has the following properties. Recall this is where y minus k quantity squared is our positive term. So what does that mean? Well, that means when we think about vertices that the x coordinate stands still and we move out, up and down from the k position. And just a reminder of what that would look like. Let's again create a sketch. Say that this is my center, this is a vertex, and let's make that a little more believable. This is another vertex. So we still have that property that the distance from the center to the vertex is a, but because we've moved in the y direction, while my center was hk, my vertex point will now be hk plus a. And down below, again moving off by a, our vertex point, our new point is going to be hk minus a. And our other points would follow as above. So for foci, we've got h, k plus or minus c, and the asymptotes, happily, they don't change at all. Asymptotes are still going to be y minus k and x minus h. The part that did change, remember, it was that we did a over b instead of b over a. Now, you may wish to refer to these charts when completing the problem set. Once you have determined values for a, b, and c, the subsequent work of determining vertices, foci, and asymptotes using HK simply demands precise implementation of the formulas above.